Ever wonder how your phone recognizes your face in a split second? How Netflix seems to read your mind and suggest the perfect show? Or how your car's navigation system predicts traffic jams before they happen? It's not guessing, and it's definitely not magic, it's learning. But the way computers do it. And it all comes down to something called the machine learning pipeline. You see, every single piece of artificial intelligence you interact with daily, from Instagram's photo tagging to Spotify's music recommendations, follows this exact same learning process. By the end of this video, you will know exactly how a computer transforms raw information into smart decisions. No computer science degree required. Think about how you learned to ride a bike. First, someone showed you examples. Maybe you watched other kids riding, then you practiced, probably fell down a few times. Someone checked how you were doing, gave you feedback. Eventually you could ride on your own and even tackle new routes you'd never seen before. Machine learning works exactly the same way, just with data instead of bicycles. The machine learning pipeline has 5 essential steps: add data, training, testing, prediction, and feedback. Let me show you how this flows together. First, you give the computer examples to learn from. That's the data phase. Then, the computer practices finding patterns in those examples. That's training. Next, you test how well it learned by giving it completely new examples. That's testing. Finally, the computer uses what it learned to make decisions about brand new situations. That's prediction. And just like humans, computers can improve over time if you give them feedback about whether they got things right or wrong. This pipeline isn't just theory, it's literally how every artificial intelligence system you use was built. Everything starts with data, and here's something most people don't realize. The quality of your artificial intelligence system depends entirely on the quality of your data. Think of data as the fuel for your artificial intelligence model. Put in messy, incomplete, or biased data, and you'll get messy, incomplete, or biased results. Let me give you a real example. Imagine you're building an artificial intelligence system to recognize different dog breeds in photos. If your training data only includes pictures of golden retrievers taken in sunny parks, your system will struggle to identify a wet poodle photographed indoors. The data you choose literally determines what your artificial intelligence can and cannot learn. This is why data scientists, the people who prepare data for machine learning, spend about 70% of their time just cleaning and organizing information. They're removing duplicates, filling in missing values, standardizing formats, and making sure the data represents the real world accurately. Here's the crucial point. If you want to understand whether an artificial intelligence system is fair and accurate, always ask about the data. What information was collected? Who was included or excluded? What time period does it cover? These questions reveal more about artificial intelligence reliability than any technical specification. Now comes the fascinating part. Training is where the computer actually learns to spot patterns in your data. But unlike human learning, computers can process millions of examples in minutes and identify patterns that would take humans years to discover. Let's break this down with a concrete example. Say you're training an artificial intelligence system to detect whether an email is spam or legitimate. During training, you feed it thousands of emails that you have already labeled as spam or not spam. The algorithm starts making guesses about what makes an email suspicious. Maybe it notices that emails with phrases like urgent action required or click here now tend to be spam. Or it discovers that legitimate emails often include the recipient's actual name, while spam emails use generic greetings. With each example, the algorithm adjusts its internal understanding, getting slightly better at distinguishing patterns. Here's what's really amazing. The computer isn't just memorizing specific emails. It's learning the underlying characteristics that separate spam from legitimate messages. This means it can identify spam emails it has never seen before, even if spammers change their tactics. During training, the algorithm goes through this adjustment process thousands or even millions of times, constantly refining its ability to recognize the patterns that matter. This is why training can take hours, days, or even weeks for complex artificial intelligence systems. But here's the critical question. How do we know if our artificial intelligence system really learned or if it just memorized the training examples? This is where testing becomes absolutely essential. Remember how in school, your practice tests use different questions than your final exam? Machine learning works the same way. We deliberately hide some data during training, typically about 20 to 30%, and save it for testing. And this testing data contains examples the artificial intelligence has never seen before. This prevents something called overfitting, which is basically the computer equivalent of a student who memorizes practice test answers, but doesn't understand the underlying concepts. An overfitted model might get perfect scores on training data but fail miserably in the real world. Let's say you're testing that spam detection system. You'd give it emails from your hidden test set and see how accurately it identifies the spam versus legitimate messages. If it performs well on this completely new data, you know it truly learned to recognize the spam patterns. If it performs poorly, you need to go back and improve your training data or try a different approach. Testing reveals the truth about artificial intelligence performance. This is why you should always ask about test results when evaluating any artificial intelligence system, especially those used for important decisions like hiring, lending, or medical diagnosis. Once your model passes testing, it's ready for the real world, making predictions on completely new data. This is where artificial intelligence systems prove their value by solving actual problems. But here's something most people don't realize. The best artificial intelligence systems never stop learning. They use feedback to continuously improve their performance. Every time you thumbs up a YouTube video, correct Siri's interpretation of your voice command, or rate a Netflix recommendation, you're providing feedback that helps these systems get smarter. Let's look at how this works with your phone's photo app. When it automatically tags people in your pictures, you might correct it if it identifies someone incorrectly. That correction becomes new training data, helping the system learn to recognize that person more accurately in future photos. This creates a powerful feedback loop. Artificial intelligence makes a prediction, humans provide feedback, the system learns from the feedback, and future predictions improve. It's like having a study partner who helps you get better over time. However, this also means we all bear some responsibility for artificial intelligence development. The feedback we provide shapes how these systems evolve, which is why it's important to engage thoughtfully with artificial intelligence technologies. Now, you might be thinking, this is interesting, but why do I need to know this? Here's why understanding the machine learning pipeline is incredibly valuable, no matter who you are. If you're a student, this knowledge gives you a massive advantage. You can now build your own artificial intelligence projects, understand how the technology shaping our world actually works, and develop skills that will be essential in almost every future career. Employers are desperately seeking people who understand artificial intelligence. Not just programmers, but professionals in marketing, healthcare, education, finance, virtually every field. If you're a teacher, the pipeline becomes your roadmap for hands-on artificial intelligence education. Each step can become a classroom activity. Students can collect and clean data, design simple training exercises, test their models, and discuss the ethical implications of their results. This transforms abstract concepts into engaging, practical learning experiences. If you're a parent, this knowledge helps you guide your children in an artificial intelligence-powered world. You can evaluate whether the artificial intelligence systems your family uses are making fair and accurate decisions. You can ask informed questions about the technology in your children's schools and help them become critical consumers of artificial intelligence rather than passive users. Most importantly, understanding this pipeline makes you a more informed citizen. When you read news about artificial intelligence bias, algorithmic discrimination, or automated decision making, you'll understand the underlying issues and can participate meaningfully in important conversations about artificial intelligence governance. The machine learning pipeline gives you a framework for understanding, evaluating, and even building artificial intelligence systems. But there's a crucial issue we haven't addressed yet. What happens when this pipeline goes wrong? In our next episode, we'll explore one of the most important challenges in artificial intelligence development: bias. We'll discover how biased data leads to unfair artificial intelligence systems, learn to recognize bias in the wild, and most importantly, understand how we can build artificial intelligence that's not just smart, but also fair and equitable. This isn't just about technology. It's about justice, equality, and making sure artificial intelligence serves everyone fairly. If you want to be part of building a better artificial intelligence future, hit subscribe, turn on notifications, and join us for this critical conversation about artificial intelligence ethics. Together, we are not just learning about artificial intelligence, we are preparing to shape it responsibly.
Guys, I am creating this series because I mentor high school students here in Bronx, New York, and I know many of them don't have access to AP computer science classes. So these micro learning sessions are aligned with the AP computer science curriculum, and every lesson includes exercises and guides for both the students and teachers. To get the most out of them, make sure you complete each exercise before moving to the next session. Uh, Look, this is an open source learning project, completely free, and my way of giving back. I invite teachers to collaborate with me, share feedback, and help improve this resource so that together we can give more students the opportunity they deserve.